Thank you for listening. This course was created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional podcasts, books, newsletters, and cool merchandise await. Let's get started. Explainability is one of the most discussed and important themes in responsible artificial intelligence because it directly addresses how people understand and relate to automated decisions. The purpose of explainability is to open the black box of AI just enough to make its inner workings accessible without requiring every stakeholder to become a machine learning expert. It enables users and developers to see not only what a system predicted, but also why it made that choice. This transparency helps build trust between humans and machines by reducing the sense of mystery or arbitrariness. It also supports accountability, since organizations must be able to defend and justify the outputs of their systems when challenged. In regulatory environments, explainability often becomes a requirement, ensuring that decisions affecting rights, safety, or financial well-being are open to review rather than locked away in opaque algorithms. When we break explainability down, it reveals several dimensions that must be addressed simultaneously. Transparency serves developers and auditors, ensuring that the system's logic can be inspected. Comprehension is aimed at end users, providing explanations in language and form that they can understand without specialized training. Interpretability caters to technical teams, giving them the ability to diagnose, debug, and refine models. Finally, traceability matters for regulators who need to confirm that every stage of the process can be reconstructed and validated. Each of these dimensions highlights that explainability is not a single outcome but a layered concept. Meeting one dimension without the others risks creating gaps, such as a system that auditors understand but users cannot, or one that end users find simple but regulators see as inadequate. Different stakeholders naturally prioritize different aspects of explainability. Users want accessible explanations that fit their context, something they can grasp quickly and act upon. Regulators need thorough documentation that demonstrates compliance with laws and guidelines. Engineers, on the other hand, rely on detailed technical clarity so they can debug models, investigate failures, and improve accuracy. Leadership looks for assurance that risks are being managed and that AI systems align with corporate values and reputational priorities. These varied perspectives mean that explainability cannot be approached with a one-size-fits-all mindset. Instead, it must be tailored, often with layered explanations designed to meet the needs of each group while staying consistent at the core. One of the trickiest challenges lies in balancing transparency with comprehension. Technical openness, such as exposing the raw code, parameters, or mathematical weights, may satisfy experts but will overwhelm lay audiences. Simplified explanations, by contrast, make outputs easier to grasp but risk omitting important details that matter for accountability. The solution often lies in layered disclosure, where high-level explanations are offered first, with options to drill down into more technical details if desired. This approach mirrors financial reporting. A summary gives the big picture, while footnotes and appendices provide depth for those who need it. Balancing transparency with comprehension is critical for building systems that serve all stakeholders, rather than privileging one group's needs at the expense of others. Explainability matters most where stakes are high. In healthcare, clinicians must understand why a system recommends one diagnosis over another, since their decisions can mean life or death. In finance, regulators demand evidence of fairness in credit scoring, ensuring that algorithms do not discriminate unlawfully. In law enforcement, due process requires that automated recommendations be subject to human reasoning and review, not accepted blindly. Education technologies also depend on trust. Teachers and students will only adopt them if they can see how results are generated and whether they reflect fairness. Each of these domains illustrates that explainability is not an academic luxury, but a safeguard in environments where people's rights, livelihoods, and safety are on the line. Trust and adoption flow naturally from strong explainability. When people understand the reasoning behind outputs, their confidence in AI systems grows. Clear explanations reduce skepticism, showing users that results are not arbitrary. This transparency makes people more willing to adopt new technologies, even when those technologies disrupt established ways of working. Over time, this trust fosters sustained engagement, where systems are not just tried once, but relied on continuously. Organizations that provide meaningful explanations also signal respect for their users, acknowledging their right to understand decisions that affect them. In this way, explainability becomes both a technical design choice and a cultural commitment to openness. Explainability also serves as a foundation for accountability and redress. When a system's decisions can be explained, individuals have the ability to challenge outcomes they believe are unfair or mistaken. This creates pathways for appeals, whether in hiring, lending, healthcare, or legal contexts. Explanations provide the evidence needed to investigate errors and make corrections, ensuring that harms are not simply accepted but actively addressed. From a legal standpoint, explainability supports obligations around fairness and due process, demonstrating that organizations can justify the decisions their systems produce. Equally important, explanations create traceable accountability chains. If a failure occurs, investigators can reconstruct what happened, who was responsible, and what can be done to prevent recurrence. Without explainability, these processes collapse, leaving only opaque results with no clear path for recourse. Regulation is becoming one of the strongest drivers for explainability. Privacy and data protection laws, such as the General Data Protection Regulation in Europe, already mandate that individuals have the right to meaningful information about automated decisions that affect them. Proposed AI-specific laws extend these requirements, especially for systems classified as high risk. Consumer protection principles increasingly emphasize clarity, demanding that companies not mislead users through opaque processes. Audits and reviews are also expanding in scope, requiring organizations to present clear documentation of how decisions are made and explained. For practitioners, this means explainability is no longer optional. It is a compliance necessity. Regulatory drivers push organizations to embed explainability into governance frameworks, rather than treat it as an afterthought. The risks of operating without explainability are significant. Opaque systems create distrust among users, who may feel alienated or skeptical about results they cannot understand. Technical teams struggle to diagnose issues when outcomes are inscrutable, slowing down development and creating hidden vulnerabilities. Regulatory penalties loom larger when organizations cannot demonstrate fairness or provide reasons for automated actions. Perhaps most concerning, harmful outcomes may persist without accountability, as affected individuals have no way to question or appeal. In such environments, the absence of explainability undermines both social trust and technical robustness. It turns AI systems into black boxes that no one developers, regulators, or users can confidently oversee or control. For developers themselves, explainability has direct, practical benefits. Clearer insights into model performance help teams understand strengths and weaknesses, rather than being surprised by failures. Debugging becomes more efficient when explanations point to why a model misclassified certain cases, enabling faster correction. Collaboration improves as explanations provide a shared language across technical and non-technical teams, reducing communication barriers. Development cycles also become more efficient, since explainability highlights flaws early rather than allowing problems to propagate into production. For engineers and data scientists, explainability is not just about user trust, it is also about technical effectiveness, reducing wasted effort, and accelerating improvement. At the same time, explainability carries its own limitations. Oversimplifying complex models in the name of clarity can create explanations that are technically inaccurate or misleading. Users may walk away with a false sense of understanding, thinking they know how the system works when they do not. Excessive transparency can also expose sensitive intellectual property, undermining competitive advantage. And even when explanations are accurate, different stakeholders may interpret them in conflicting ways, leading to confusion rather than clarity. These limitations highlight the need for careful balance. Explainability must strive for accuracy without sacrificing accessibility, while also protecting business and security interests. Another tension lies in balancing explainability with privacy and security. Detailed explanations risk disclosing personal data, particularly if outputs reveal sensitive attributes about individuals in a dataset. Similarly, exposing model details could reveal vulnerabilities that malicious actors might exploit. Organizations must therefore find a middle ground, offering explanations that build trust without creating new risks. Controlled disclosure becomes the practical solution, where explanations are tailored to context and audience. For example, a regulator may need more detail than a casual user, and a developer may require more depth than a company executive. Balancing these needs ensures that explainability enhances safety rather than undermines it. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. In practice, explainability is most effective when it is integrated directly into development workflows rather than bolted on afterward. Teams can use specialized toolkits that generate explanations alongside predictions, making them a natural part of the process rather than a separate step. Documentation can be aligned with broader governance requirements, ensuring that explainability supports audits and compliance reviews. Training programs for technical and non-technical staff alike help everyone interpret explanations correctly and apply them responsibly. By weaving explainability into the daily rhythm of design, training, and deployment, organizations normalize it as part of responsible development, not an optional add-on. This approach also reduces costs and resistance, since explanations evolve with the system rather than being created retroactively. Explainability can also be thought of at different levels. Local explanations describe why a model made a specific prediction for a particular individual or case. Global explanations, by contrast, describe the overall patterns and logic the system follows, giving insight into general behavior. Temporal explanations focus on how systems evolve over time, especially when models are retrained or updated. Increasingly, multi-level approaches combine these perspectives, offering a layered understanding that covers individual decisions, overall design, and long-term change. This granularity matters because stakeholders often need explanations at multiple levels simultaneously. Patients may want local clarity, while regulators require global and temporal transparency. Human factors strongly shape how effective explanations are in practice. Explanations must be designed with attention to cognitive load, ensuring that the information provided is digestible and not overwhelming. Avoiding jargon and technical terminology helps users engage with content meaningfully. Testing explanations with end users provides valuable feedback about what works and what confuses, guiding iterative refinement. Just as user interface design considers how people interact with technology, explainability design considers how people understand it. A technically correct explanation that overwhelms or alienates its audience fails its purpose. Iteration and user testing ensure that explanations are not just accurate but genuinely useful. Organizations that embrace explainability often see broader benefits beyond the technical sphere. Transparency enhances resilience against external criticism, since organizations can defend their systems with clear reasoning. Reputation improves as stakeholders recognize that openness signals respect and responsibility. Disputes with users, regulators, or advocacy groups are reduced when explanations are available, since misunderstandings can be resolved through shared understanding. Compliance readiness also strengthens, as organizations with embedded explainability can more easily meet evolving legal requirements. In this way, explainability serves as both a defensive and an offensive tool. It protects against harm while also building goodwill and competitive advantage. Measuring explainability may sound counterintuitive, but organizations increasingly need to assess whether their explanations are actually working. Metrics can be developed to gauge the clarity and interpretability of explanations, testing how well stakeholders comprehend them. User studies can evaluate whether explanations increase trust, reduce errors, or improve decision-making. Benchmarking against industry standards helps organizations track their performance relative to peers. Over time, improvements can be tracked to show whether explanation practices are becoming clearer, and more effective. Without such evaluation, organizations risk assuming their explanations are helpful when they may, in fact, be confusing or misleading. To sustain impact, explainability should be integrated throughout the AI lifecycle. At the design stage, teams can anticipate where explanations will be needed and plan accordingly. During training, explanations can accompany validation metrics, providing richer insight into model behavior. Evaluation reports should include clear accounts of decision logic, and dashboards during deployment can make explanations accessible to operators and users. In production, updates must preserve explainability, ensuring that explanations remain valid even as systems evolve. This lifecycle integration reinforces the message that explainability is not an afterthought but a continuous thread, woven into every stage of responsible AI development. Looking toward the horizon, explainability is becoming a vibrant area of research with promising new directions. Human-centered explanation design emphasizes tailoring explanations to the needs, preferences, and contexts of users rather than focusing solely on technical completeness. Automated explanation generation is advancing, aiming to provide meaningful insights without requiring constant human oversight. Multimodal explanation techniques are emerging, helping people understand systems that combine text, images, audio, or video in their outputs. Standards for cross-industry use are also being discussed, which would help organizations navigate expectations consistently across different regulatory and cultural environments. These developments suggest that explainability will not remain static but will continue to grow more sophisticated, practical, and aligned with human needs. Because explainability touches on so many domains, cross-disciplinary collaboration is essential. Psychologists and designers contribute insights into how humans best process and absorb information. Legal experts guide the language and detail required for compliance, ensuring that explanations satisfy regulators as well as users. Technical experts guarantee that explanations remain valid and faithful to the system's actual behavior. Governance bodies add oversight, validating that explanations are consistent with organizational commitments and societal expectations. This collaborative mix ensures that explanations are not only technically accurate, but also legally compliant, socially meaningful, and easy for diverse audiences to understand. It is only through such cooperation that explainability can fulfill its promise. When we step back, several practical takeaways emerge. Explainability builds trust, accountability, and transparency, all of which are essential for responsible AI. Different audiences require different types of explanations. What satisfies a regulator may overwhelm a user, and what reassures a manager may not help a developer. While risks exist, such as oversimplification or disclosure of sensitive information, the benefits consistently outweigh the costs. Effective explainability requires balance, providing openness without sacrificing privacy or security. Above all, organizations that invest in explainability are better positioned to sustain user trust, meet regulatory expectations, and adapt to emerging governance standards. The forward outlook suggests explainability will only grow in importance. Regulatory mandates are likely to increase, requiring organizations to produce explanations as part of compliance regimes. Automated explanation tools will become more widespread, helping scale explainability across complex and fast-moving environments. As AI systems become multimodal, explanations will need to match this complexity, helping users understand how different data types interact in a model's reasoning. Standardization across industries will reduce fragmentation, creating clearer expectations and more consistent practices. These trends make clear that explainability will soon be considered not a luxury, but a baseline requirement for any responsible AI system. In drawing this episode together, we can see that explainability serves multiple intertwined purposes. It enables understanding, builds trust, and provides the foundation for accountability and redress. It is driven by both ethical commitments and regulatory requirements, and it delivers benefits to developers, organizations, and end users alike. At the same time, it requires careful balance between transparency and comprehension, between openness and privacy, between technical depth and human accessibility. Organizations that master this balance not only reduce risk, but also create long-term value, demonstrating their seriousness about fairness and responsibility. As we move forward, the next episode will turn from the broad theme of explainability to the more specific challenge of interpretable models. Where this episode has focused on why explanations matter and how they can be delivered, the next will explore how models themselves can be designed for interpretability. This shift brings us from the external presentation of explanations to the internal construction of models that are inherently more understandable, providing the technical foundation for everything we have discussed here. Thanks for tuning in to Bare Metal Cyber, your trusted source for cybersecurity educational materials, news, and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.